Imagine zooming in on an atom. You expect to see something solid, a tiny, clean, defined sphere. But instead, you see a ghost, a blur, a cloud, something that exists but refuses to stay put. And here's the disturbing part. This isn't a limitation of our technology, it's how reality actually works. Stay with me, because what you're about to hear will permanently change how you think about matter itself. Most of us learned the same atomic model in school, a nucleus in the center, with electrons orbiting it like tiny planets. That image is everywhere, in textbooks, animations, and posters, but it's completely wrong. Electrons do not orbit, they do not have paths, and they are not tiny balls. So why are we still taught that picture? Because the truth is far stranger and much harder to accept. Here's the question that physicists struggled with for decades. Where is the electron? Not where should it be, or where was it, but where is it right now? And the answer shocked the world of science. You can't know. Not because we lack precision, but because the universe literally doesn't allow that answer to exist. According to quantum mechanics, an electron doesn't have a precise location, a definite speed, or a fixed shape. Instead, it exists as a probability cloud, a region of space where the electron might be. This isn't a theory anymore. This has been experimentally confirmed. And once you understand why, there's no going back. So why can't we just look at an electron? First, it's unbelievably small. Second, it moves insanely fast. But the real reason is more unsettling. The moment you try to observe an electron, you change it. This isn't philosophy. It's physics. And it's enforced by a fundamental law of nature. It's called Heisenberg's uncertainty principle. You can know where an electron is, or how fast it's moving, but you can never know both at the same time. The universe literally prevents certainty at the smallest scale. So, electrons aren't hidden behind a veil, they exist as the veil itself. And yet we've still found a way to map them. If light can't see atoms, how do scientists do it? They don't look, they feel. Welcome to the world of quantum microscopy, where images are built not from photons, but from quantum interactions. And what these incredible machines reveal is truly haunting. Scanning tunneling microscopes, for example, use a needle just one single atom wide. When it gets close enough, electrons actually tunnel through empty space. Something classical physics says is impossible. The current changes based on the electron density. In other words, scientists are mapping probability itself. Atomic force microscopes do something similar, measuring forces so small they border on the unreal. And the images they produce? They don't look solid at all. What appears on the screen isn't a sharp object. It's a haze, a glow, a cloud. These are electron orbitals, the regions where electrons are most likely to exist. Not particles, not waves, but something in between. This is wave-particle duality made visible. Those blurry shapes aren't flaws in the image, they are the truth. They confirm that electrons are not objects in space. They are mathematical probabilities given a physical form. Reality, at its deepest level, is not made of things, it's made of chances. And this isn't just abstract science. Electron clouds determine chemical reactions, the strength of materials, and how semiconductors behave. Your phone works because of these clouds. Your body exists because of them, and they reveal something deeply unsettling. Everything you think is solid, your hands, the ground beneath you, the planet itself, is mostly empty space, held together by invisible probability clouds. Matter isn't solid, reality isn't fixed, and certainty was never real to begin with. If this changed how you see the universe, you're already starting to think like a quantum physicist. Thanks for watching, and don't forget to subscribe for more journeys into the unknown.